Those are gonna bug me. Get out of here. Dust. This is gonna be a hard one to keep all of you interested, but I'm up for the challenge. I've been following AI for a long time. I remember videos about this new fascinating autocomplete thing, and people were making hilarious videos of it, like auto-completing a book, so it like redo Harry Potter, and it was awful.
Harry Potter and the portrait of what looked like a large pile of ash. Magic. It was something that Harry Potter thought was very good. A kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Ron's Ron shirt was just as bad as Ron himself.
And that's what was funny about it. Now, AI is all over the news. It's in everyone's ears. Every startup is AI powered. Listen, I'm gonna need you to stick with me because I promise it's not gonna get too technical. It's gonna be nice and easy to understand, and I'm gonna explain it. I feel like I'm scaring you away. Okay, so I've been following AI for a long time, and I've always been interested in it. Same thing with like Jarvis and all of that. It's kind of been just a brief, not a brief, but like a glancing interest. Until somewhat recently though. You know, I've been a software developer for about 5 years, and so I got technical knowledge to understand it now at a deeper level. I've gotten even more into it. One of my recent hyperfixations has been a new AI. There's some background information you gotta know before you know what I'm doing. Okay, so the first thing you gotta know, neural networks. What are neural networks, you might ask? And I'm so glad you asked that question. They're a way for a computer to learn. They are not the only way. There's many others. You can kind of think of it as a blueprint or a recipe on how a computer is going to learn. Steps of instructions to follow, essentially. Neural networks look like this, and they are roughly based off of the brain. You have these nodes, and these nodes are what you could consider to be neurons. So I know this looks super complicated, but please, it's actually really easy. You need like first grade level math to understand this. So each of these nodes send numbers to one of these neurons. They are then multiplied by a weight and a bias. These weights and biases are the whole thinking. It's what is tweaked when you train an AI. Essentially, all neural networks are just taking numbers and computing more numbers. So you feed it a bunch of data, you feed it a bunch of cute images of cats and dogs, and then these numbers will get adjusted until it's thinking. These numbers also need to be kept in memory. They need to be remembered because they're the ones that do the multiplying. When I learned about this, I found neural networks very interesting, but I also thought it was a bit wasteful and not quite like an actual brain. This is a neuron. These, I really hope I have the editing skills to do this. The sodium ion channels let in sodium ions, which are negatively charged sodium ions that essentially build up an electrical charge. So neural networks essentially mimic just a single neuron, getting a compute and then sending out a process. But that's not how the brain works, because actually one of the main keys to learning and the brain is not the neuron itself. It's actually the connections between the neurons. It is the synapses and the dendrites. The synapses is the gap between the neurons, so not the synapses. It's the dendrites and it's the dendrites that are mainly responsible for learning, because they are what deliver the electrical charge to other neurons. And they don't stay put. They like to move. Learning is actually a physical change in your brain. It happens when the dendrites move in different locations. There's more of them in specific neurons, and they get clustered. If you were to imagine a neural network, each neuron is connected to each other neuron. If our brains operated like this, we would all be seizing out horribly and violently, because that's essentially what a seizure is when your brain just all fires at once, right? Well, it takes a lot of computer power to compute these. So the little example I showed you, it was kind of small, right? But that's just an example. If we're talking something like ChatGPT, we're talking on the order of billions of parameters. Those little numbers that I was talking about getting tweaked. Took a really fun neuroscience class back in Moore Park College. Taught me a lot of this. I realized that it's not quite mimicking the brain, and so I didn't do anything with that for a while. But one day I saw this image right here. This is an image of a certain type of database. It's called a vector database. We're not getting into it. When I saw that image, it immediately sparked in my brain images I've seen of this, of neurons, of semantic learning, of what it looks like, a representation of a brain, essentially, with all those little connections and things. So I wanted to know, could you build a neural network like that? And for a long time, I did not have the coding skills to do it. I would say shortly after, I was looking for a project to just have fun with, mess around with, type it up and practice, learn, all the good things about having little fun projects. I called this hyperfixation of mine the multidimensional neural network. I basically just had the idea to pull it out, put it into 3D, rather than, if you look at the graph of a neural network, it's flat, and it only goes that way. So the whole point was that it would reduce how many times you would need to run the math. A neuron would only compute if it's within a certain distance of another neuron. So this guy way out here isn't within this circle. So you don't run the numbers for him and everyone outside. So it creates just a little pathway that pushes through this whole 3D network, and you end up with your answer. I did exactly that. Wrote it up in Python, and took me a while, but then I tested it, and it didn't work. It was way too slow. Way too slow. I was comparing it to, a standard one, and it would do it in milliseconds. It would compute through, and mine would be still going. It'd take like 10 seconds to do one pass through the neural network. But I eventually learned from listening to a podcast that that's not necessarily due to the architecture that I had thought up. It's actually just the language. So, rewrote the whole thing. Did it again in a faster language. And it's kind of working. The only problem is, I am not as smart as I sound. I only completed one level of calculus. And from what I understand, in order to write an algorithm to train this thing, you need multi-dimensional, multivariable calculus, which is more than I have. So I've been getting stuck in the weeds and not able to train the thing. It operates, it forward passes. That's been one of my hyperfixations recently. It's gotten me to learn a lot about AI and how they operate and really under the hood, because I just started writing this thing. It was like 3 years ago. And yeah, here we are. There you go. That's been one of my side projects, one of my hyperfixations. Hopefully you learned a little something about AI. Bye.